All right, 8.2, graphing polynomial functions. So today we do want to get a little more specific on graphing, but we're not going to get real in depth again. We're still going to use that end behavior, so that's going to be the first thing that we put onto our graphs. And then we're going to look at adding some zeros and going from there and being able to determine a few things with those, okay? Now, again, the good thing for those in my class currently that's using Pearson, you're not going to have to physically put those into the computer. You get a quick sketch, and then you're going to find the graph that most matches what you have, okay? And so we're going to look for those pieces, all right? So that's what we're going to do. Now, got a couple of definitions. They're pretty wordy, so I'm going to share those using my screen again here. And so let's look over that real quick. All right, so our first couple of definitions, our first one states that if we have a polynomial with degree n, so our biggest power on those, okay? Then the graph, when we're looking at it, has at most n real zeros, okay? I can have less. So for instance, if I had x to the third, that means that I could have as many as 3 real zeros, okay? But I could have less than that. Now, there are some other rules that talk about how many less, things like that. We're not going to get into that at this point. We're not ready for that. For those of you that go into pre-calculus, you'll learn more about those. They're going to dive a lot deeper into that graphing part and get more specific on those pieces. And so we can look at them there, all right? But here, we're not going to do that, okay? We also have this, at most, n x-intercept. Well, a 0 means the y value is 0, so that x value has to be the x-intercept. And so that's what's happening there. So your number of zeros is your number of x-intercepts. Those things will always be the same for those, okay? Now, again, it can be at most. And then our last part there, part C, at most, n minus 1 turning points, okay? That means where it loops over. So if we think about an x squared, that parabola shape, x squared is 2. You subtract 1, it's got to be 1 turning point on it for those. And so that can happen. Now, again, that's an at most with those pieces. It could always be less than that. Our second definition is called the intermediate value theorem. And it states that for any polynomial, if A does not equal B, we have 2 different numbers. If we take those numbers and plug them in, and P of A and P of B, so our Y values have different signs, then there's at least 1 0 between those, okay? And so it means it's crossing over. We're going from a positive Y value to a negative Y value as we move across. So it has to cross over that x-axis, which means there's an x-intercept, which means there's a 0 for those, okay? So we plug in 2 different numbers, and then our result, one's positive, one's negative. That means there must be a 0 between A and B somewhere, okay? Now, if they do not have opposite signs, so they both come out as positive or both come out as negative, we don't know if there's a 0. There could be. It just could mean that there are other things going on there. We pick things that are too far apart. It could also mean that it goes down and touches and comes back up. It never actually crosses the line with those. So there are a lot of different options that could be happening there for that, okay? And so we just don't know anything. We can't determine if there's a 0 in between those values if they are the same signs, right? So we're going to use that here to be able to see what's going on in these examples, all right? Okay, so let's look at our first example here. So number 1, if we have P of x equals x to the 5th minus x squared plus 6. I want to know what is the maximum number of zeros. So the maximum number of zeros. Well, we go and find our biggest power, our leading term here, and so that's going to be 5 every single time. And whatever that power is, that's what it's going to be. What is the maximum x-intercepts. Okay. Now the x-intercepts are the number of zeros, and so they're the same thing, 5 in this case. Okay. And then finally, the maximum turning points, or number of turning points. Right? Now, that's always going to be that power 5 minus 1, which is 4. Okay, that's the maximum number. We could always have less than that, but that's the maximum number that we can have. Okay? All right, now let's start trying to apply some of that here. And so I want to graph. So we'll look at a couple of examples here. What if I have f of x equals negative x to the third minus 2x squared? Okay. All right, so we want to know a few different things here when we go to look at this graph. All right, because we don't have a graphing calculator, we got to break this thing down for it. Now, before I even start trying to break it down, I want to look at that leading term. Here, my leading term is this negative x to the third. So since this is an odd and this is negative, that lets me know that I should have a graph that has this type of shape to it. Now, we don't know what's happening in the middle, but it's going to have that essential shape to it, okay, for those. Now, the next thing that we need to do is try to find the zeros. But in order to find the zeros, we need to factor this piece because it's not just an x, right? So let's do that. Looks like we have an x squared in common, and we can take that negative out with it. So negative x squared, and then that's going to leave me with x plus 2 because I'm taking the negative out, right? Well, to find our zeros, we do negative x squared equals 0. When we manipulate that, that means x equals 0. Okay, because there's no adding or subtracting. So when we take the negative off, it stays 0. We take the square root, it stays 0. And so that's a good thing. I'm going to box that in so I don't lose it. So that's the first part there. So now we need to do this one. So x plus 2 equals 0. So x equals negative 2. Okay. Again, let me box that in. I'm just boxing that in. That's when you highlight or people highlight those just so you don't lose them. Okay. It's not that I'm typing in that piece because we're going to graph here on these. Okay. All right. So now we're going to look at our graph. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we're going to graph those 2 points. We know that x equals 0 is an x-intercept. So here, and then x equals negative 2 is also an x-intercept. Now, I don't know a lot of things here for these. I do know that this has to come into this point. So this way has to be going up, and this way has to be going down because there's no other zeros going on. Okay, so for the most part, that has to be happening. All right. Now, in between here, we're not sure what happens. You know, does it come back down, go through, those types of things, okay, and where it goes. So we do have enough information right now because, again, you are going to have multiple choice. You're not going to have to physically graph this in the computer to pick it out. This would be enough information to pick out. You pick out the one with those zeros and with the other pieces. But I just want to check real quick. What if I plug in -1 to that function and work it out? Well, if I plug in -1 here, I'm going to get -1, +1. That's going to become stay -2. So 1 minus 2 is going to be a -1. So I'm just plugging that in here. I picked this -1 here for that. And so it means it's going to have this shape. So you could always do that. You can pick other points if you want to be a little more exact for that, okay, piece. But just that other information would be enough to pick out the right graph. You know, look at those zeros. You can zoom in on those graphs. Which one has the zeros I found? And then which one of those that have the zeros, which one have the right end behavior? And that's going to do it for us. And there's my graph. Okay. All right, let's look at another one. So g of x equals x minus 4, x plus 1, x minus 2. Okay. All right, so we got a couple of different things here. It's already factored. I'm going to go ahead and bust out those zeros, and then we'll go back and talk about the leading terms. So it's all about what form it's in on what I do first. So here, for my zeros, I have an x equals 0. So that one's done. I have an x minus 4 equals 0, so x equals 4. I have an x plus 1 equals 0, so x equals negative 1. And then I have an x minus 2 equals 0, so x equals 2. So I had 4 zeros there on that one. So when I go to graph, I'm going to have 4 dots on my x-axis straight up on that. Okay. Now, what about that leading term? So I'm going to put that over here, leading term. Well, if we were to multiply this out, it'd get real ugly real quick, but we could do a quick trick. This is x to the 1, there's a 1, there's a 1, there's a 1. So really, we add those 1, 2, 3, 4, and because there's no numbers in front of the x's, we're going to end up with x to the 4th, and they're all positive. So that means it's a positive x to the 4th. That tells me that I should end up with something like this, okay? Where everything is going the same direction because it's even, all right? So let's see what that graph looks like. That's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. All right, so we have x equals 0. X equals 4, x equals negative 1, and then x equals 2. Okay. We also know the last ones will have to go up somehow. All right, now I'm not, those are just estimates. They're not perfect for those, okay? And so then we would see what's happening between those pieces. So if we plugged in some things and we could get some answers for that here. I'm going to plug in 1 just real quick. So we get 1. That would be negative 3 times 2, which is going to be negative 6 times negative 1, which is positive 6. So it looks like we should get here 6. So this would actually go way up on this piece, right? So somewhere up here. So this is probably going to go down, up, down, up, something to that effect for those, okay? It's not perfect, okay? I didn't go find the rest of them. It may have bigger loops, and that's okay. Right now, we're just sketching for those pieces so we can look at our graphs on the computer and tell which one. All right, we'll get more in depth if you move on to higher math. This may go down further. I would have to plug in 3 to see what we get there on those. It may be very similar actually for that. Okay, it may go way down. So we're just going to leave it kind of in this shape, but you're going to get something with that W shape to it there for that graph. Okay, so again, this is not a perfect rendering for those. Right. Now, the last thing that we want to look at here today, so number 3, we want to use the intermediate value theorem to determine if f of x equals x to the third plus 3x squared minus 9x minus 13 has a 0 between a equals -5 and b equals -4. Okay. All right. So if we want to be able to determine that, we got to plug those two values in and see what we get as answers. So we need to do f of -5, and then we need to do f of -4 and see what we get on each one of those. Okay. So if we do -5 to the third plus 3 times -5 squared minus 9 times -5 minus 13. So we put those in our calculators, we let that do the work for us, and we will see that we get -18. I have a cheat sheet there. I did that really quickly because I have my answer already. Okay, but your calculator will perform that for you. We plug in -4, you get -4 to the third plus 3 times -4 squared minus 9 times -4 minus 13. Then we go to our calculator, we type all that in, and we get 7. Okay, and I believe it may even ask for those answers if you're doing Pearson there. So now we compare those and we say, is there a 0 between A and B? So since -18 and 7 have different signs, then there is at least 1 0 between -5 and -4. Okay, so since our results have different signs, there's at least 1 0 in between that A and B value. Okay, now if they're the same sign, then we don't know. We don't say no. No is not the answer. It's I don't know if there is. I cannot conclude whether there's a 0 or not in there. It could be, or there could not be. So that we would have to do a lot more math to determine those pieces. Okay. So that's what you're going to do on that. You need to show me plugging it in, working it out, so that you know why you pick the answer there. Okay. So those are the things that you're going to be looking for here in 8.2.